Okay, so I'd ask you to try this question, 4 parts, with these two vectors. So A dot B. So A dot B, and remember when you're dotting, only the same terms stay. So 5I dot, I lost my negative 2I. The ij's don't stay, they all cancel, so the next term that stays is negative 6j dot 7j. And the last term that stays is 3k dot 4k. Okay, so A dot B is going to be 5 times negative 2, so negative 10. I dot I is just 1. It disappears. Negative 6 times 7 is 42 negative, and again the j dot j is 1. It disappears. 3 times 4 is positive 12. The k dot k disappears, so you're left with A dot B is equal to negative 52 plus 12 should be negative 40 for part A. Okay, part B, I want you to find the angle using the dot product. So it's going to be cos theta is equal to A dot B over the absolute of A, absolute of B. A dot B is negative 40. Absolute of A, 5 squared, 25, plus 36, plus 9, 70. Square root of 70. 2 squared, 4, 49, so 53, 63, 69. Okay, so do the math, get something here, do second function cos, and you get an angle of 125.14. I think it was really 138, but we'll round. Okay, now cross. So A cross B. So remember, in this one, it's the ones that aren't the same that stay. So 5i cross negative 2i is going to go to 0. So we do 5i cross 7j plus 5i cross 4k plus negative 6j cross negative 2i plus negative 6j cross 4k, because the j's go to 0, plus 3k cross negative 2i plus 3k cross 7j, and the 3k plus cross 4k will be 0. So A cross B. 5 times 7 is 35. I cross j is k. 5 times 4 is 20. I cross k is j, but it's negative. Yeah. Negative is going to be positive. 6 times 2 is 12. J cross I, negative k. Negative 6 times 4, so negative 24. J cross k, positive I. 3 times negative 2 is 6. K cross I is positive j. 3 times 7 is 21. K cross j is negative I. Okay, so doing the i's first, negative 24 and negative 21. So that should be negative 45 I. J, negative 20 and negative 6 should be negative 26 j. 35 and negative 12 should be positive 23 k. So A cross B should be this. So far so good, I hope and assume. This is the part that I thought it maybe could mess you up. So sine theta is equal to the absolute of A cross B. Oops, imagine those are two separate. And over the absolute of AB. All right, so 45 squared plus 26 squared plus 23 squared. Square root of 3,230. And we already did A and B up here. Root 70 and root 69. Okay, so when you do this, then do the math, do inverse sine, you get theta is equal to 54.86 degrees. Which shouldn't seem like an issue. It seems like a nice number. Except we found the same angle up here, but it was 125.14. How come the two angles aren't the same? The vectors haven't changed. They haven't moved. So why didn't we get the same two angles? I want you to stop and think about it for a minute. I could give you a hint, except I think you don't know what the cast rule is. All right, so it has to do with that cast rule that I talked about before, and then someone said you hadn't learned it. So CAST. It means that when a cosine of any angle in the fourth quadrant will be positive. Sine, cos, and tan of all angles in the first quadrant are positive. In the second quadrant, only the sine of angles over here are positive. Cos and tan would be negative. And in the third quadrant, tan is positive, but sine and cos would be negative. So then which angle is right? Well, you get 125. That's in this quadrant, right? That's this angle. When you do cosine, because there's a negative there, you get 125. But you're not going to get that same angle when you use sine because in this quadrant it's positive. So what you're getting is called the reference angle. And I don't know if you did that anywhere in your life because I don't know what math you skipped. But what you're finding with that sine is this angle. And you have to realize, like, the only way you would know that it wasn't 54.86 is by doing the cosine and seeing if you get the same. Usually we use the cosine for two reasons. One, because it's easier, because you could just use the answer from A dot B. And two, because it will give us the correct angle. Using the cross-multiplying values, it's harder in the sense that you have to find the absolute value of A cross B, and you don't know if you're getting the actual angle, if the thing is actually here and it's 54, or if that's your reference angle, and then you'd have to take it away from 180. But because we did the cosine, then we know this is the reference angle, right? And so you would write here reference angle, and then you would say therefore theta equals 180 minus 54.86 degrees. Theta equals 125.14. If you haven't done reference angles yet, they will be coming in math, and I hope the cast rule will too. So when you do sine, you often will get the reference angle, okay? But cosine will give you the actual angle, whether it's in the first or the second. All right? You could ask me about this again in class because I'm sure I just screwed you up. But just know that whenever these two angles don't match, notice they add up to 180. It will always be the cosine one that's the real angle, and this will be the angle with respect to the x-axis, and you can find the real angle then by taking it away from 180. Okay? All right, time to move to electrostatics.